Okay, so you see we have 40 over 30. That is a very big fraction. This fraction can be reduced into a simplest form. Okay, so 40 and then 4 over 3, they are the same. Okay, 400 over 300. This is the same as that. 4,000 over 3,000. 40,000 over 30,000. All of these fractions are the same because they all will simplify to 3 over 4, 4 over 3, 4 over 3, 4 over 3, 4 over 3. And you see, if I cancelled all of these zeros, cancel all of these zeros, cancel all of these zeros, they will end up becoming 4 over 3. That's what we talk about reducing fraction. But let's look at the simplest way of reducing fractions. There are a couple of ways you can do that. But let's see. You see, before we talk about reducing fraction, let's quickly do what we call so before we do reducing fractions, one of the things that is important is talk about prime numbers. Okay, prime numbers are very important, and then we say that prime numbers, they are the building blocks of every number. Every big number that you see here is based on particular factors, which will eventually lead you down to prime numbers. Okay, so 300 is the same as 30 and 10. 30 is the same as 3 and 10. 10 is the same as 2 and 5. 5 is the same as 10 is the same as 2 and 5. So what this one tells you that this 100 here is technically based on these numbers. These are the building numbers: 2 2s and 5s, 2 3s and 5. So there are 2 2s and there are 2 5s and there is 1 3. These numbers is what make 300. Let's look at an example. Let's say I have 6 over 18. So let's convert these into prime numbers. So which numbers will make up 6, 2 and 3? Which numbers will make up 18? 2 obviously, and 3 and then 3, right? If you want to know how I did that, this is 18. 18 is an even number for the starters. Okay, if every even number can be divided by 2, so that is 2, and this is 9, right? And 9 is divisible by 3 and then 3. That is why we have 2, 3 and 3. Yeah, that is for starters. I know you knew that already, so great. So now let's see. Now we can cancel out common prime numbers. Okay, so here 2 is here, it can cancel 2. We can see 3 here, can cancel 3. So what do I have here? I have nothing here. That is literally 1. So this is going to give you 1 over what is left here, 3. So you combined everything that is left there. So let's look at, for instance, I have 42 over 49. So this can be 2 times 3 times 7, and this can be 7 times 7. You got that? Yes, 7 times 7. And if I delete common prime numbers, this is what you're going to have. And so you are left with, here you are left with 2 times 3 and then 7. So you break the numbers into their building blocks, cancel out the common prime numbers, put the numbers back together. And so this is 2 times 3 is going to give you 6 over 7. Again, simple. Break the numbers out into their building blocks. Okay, their building blocks. And then when you cancel out the common blocks, put the numbers back together. Very simple. Very, very simple. Let's look at these examples. Look at these examples. We're gonna have to give you 14 over 42, 5 over 35. Let's see which one is a little bit harder. 22 over 121. Let's do last two. 240 over let's see, 240 over 165. Yeah, this should be okay, right? So let's see how we do that. So this 14 can be written as 2 times 7, and 42 can be written as 2 times 3, that is 6, times 7 is 42. And just as we did, 2 can call out 2, 7 can call out 3, and this should lead us with 1 over 3. So here you're gonna have breaking these numbers. 5 is okay. 35 can be written as 5 times 7 is 35. And again, as you may remember, 5 and 5 here can cancel out, so you have 1 over 7. And so let's look at 22 over 122. This 22 is an even number, so every even number is divisible by 2. So that's your first shot. So 2 times 11, this is 121. This is a perfect square, so remember this is 11 times 11 here. So let me give you the trick. Anytime you break the numbers into their building blocks and you are left with only prime numbers, you should be sure that the denominator should have at least one of those prime numbers in there. So even if you don't know that 121 is a perfect square of 11, so you could, as long as you are seeing 11 and you are seeing 2 here, 2 or 11, one of them should at least be a building block of 121, and that is pretty a simple thing to note. So you have 11 calls out 11, and you're gonna have 2 over 11.